Okay, good morning again everybody and happy Wednesday. Nasa gitna na naman tayo ng week 5 ng semestre. So parang pag magkita-kita tayo super pagod na tayo no kasi middle na ng week, I mean. And then we are on the 5th week, so it's almost 30% of or almost a third of the semester is already gone. So and I know things might be piling up. Tapos napansin ko rin na medyo parang natagalan kayo dun sa Lab Exer 1.2 and 2.1, ano? I was checking the submission bin yesterday and it seems that there's a good number who haven't submitted the latest problem set yet, 2.1, ano? So probably one reason kasi nagsabay nga, ito yung dahilan kung bakit ayoko sanang pagsabayin yung deadline ng 1.2 and 2.1. Medyo mabait yung mga lab instructors nyo. Sila yung nag-suggest na wag na ako magpapasa midweek, uh, week before last. Ano? Sabi nila, sir, pagsabayin mo na lang ng Monday. Kaya lang yun nga yung worry ko. Medyo matatambakan kayo. Pero I thought that LabXer 2.1 should not be a big problem for you because essentially there's nothing much new about it. Kasi ang nangyari lang naman sa LabXer 2.1 supposedly ay you will tinker a bit with the code. You will insert a couple of lines that will compute the roots of the Chebyshev polynomial. And then yun yung gagamit yung vector t dun sa code, and then i-run nyo the same code that we use for Lagrange. That's why I inserted, I think, more of analysis questions, LabXer 2.1, because I thought you should not have any much problem with it. Yung iba medyo hindi pala na fully grasp yung idea ng Chebyshev interpolation. So basically, it's the same Lagrange interpolation process. Yun nga lang, yung mga x sub j's, yung mga abscissas na ginamit natin ay hindi na lang basta-basta say equally spaced points on the given interpolatory interval, or hindi na lang sila basta-basta any arbitrary abscissas within the interpolatory interval. Hindi na lang tayo basta-basta pumipili ng mga x sub j's. Pinipili natin yung mga x sub j's para yung L infinity norm nung error ay ma-minimized. And the thing that Yuri suggested na diniscuss natin last week, para ma-minimize yung L infinity norm ng error, kailangan yung mga roots ng Chebyshev polynomials yung kailangan natin gawing interpolatory abscissas. Right? So perhaps I can show you what I did in my code para dun sa Lagrange interpolation when we discuss the implementation of the next kind of interpolation, which is still Lagrange-based. Ano? So walang pagbabago dun sa methodology ng pagkuha ng interpolatory interval. Lagrange pa rin yung gagamitin natin. Pero ngayon, yung mga abscissas o yung mga x sub j's, pipiliin natin para yung error naman ay ma-minimize with respect to another kind of norm. This time we will look at the L2 norm. Okay. So again, we first define what the L2 norm, or what we call the Euclidean norm of a function f. So the Euclidean norm of a function f, denoted by f trap between two norm bars, ano? Tapos may subscript 2 lamang dito sa ilalim to denote the L2 norm. Okay. So kamukha siya ng L infinity. Yung L infinity nga lang norm bars, tapos infinity yung subscript. So the subscript denotes kung ano yung kung anong klaseng norm yung ginagamit natin. And the L2 norm, or the Euclidean norm, is simply the integral of f of x squared from a to b raised to the 1/2. So maybe I should be more particular with it. I can say that the Euclidean norm, or L2 norm of f on the interval ab, is equal to this integral, right? So in this sense, ito namang anong pinagkaiba ng L2 norm sa L infinity norm? Well, number one, yung formula nila magkaiba. Pero conceptually, ang pinagkaiba nila ay yung L2 norm ay mas, what you call this, mas global yung pagtingin. Oops. Mas global yung pagtingin dun sa error compared sa medyo local behavior ng L infinity norm. Remember, if I have a function f of x, ito si f of x on the interval ab, Okay? Yung L infinity norm ni f of x is just the supremum of the function values. So ibig sabihin yung pinakamataas na absolute yung pinakamataas na absolute value ng function value ni f over the interval AB, that's gonna be the L infinity norm. So in this case, ito yung L infinity norm ni f kasi siya yung pinakamataas na function value or siya yung function value na may pinakamalaking absolute value. All right. So that's why I said the L infinity norm is much more of a local take on the error, because what we do, we compare the function value point by point. So kung sino yung may pinakamataas na absolute value among the function values, siya yung L infinity norm. So ibig sabihin siya yung point by point o local yung pagtingin natin sa error. On the other hand, when we talk about the L infinity norm, ang kinukuha natin ay yung integral over the interval AB ng f of x quantity squared. So kung ito si f of x, titingnan ko yung f of x squared. Halimbawa, ito yung f of x squared. Okay. Kukunin ko yung integral niya. So basically, it's the area under the curve. Tapos kukunin ko yung square root. So yung square root ng area, ito yung L2 norm. Okay. So ibig sabihin, ito ay global kasi kino-consider natin yung mga error doon sa buong or yung function values doon sa buong integral. Doon sa buong interval. Because we are summing up the squares of the function values over the entire interval. Then sort of sinasum natin, di ba? Integration is just the continuous version of a summation. So kinukuha natin parang yung totality ng mga function value ni f squared over the interval AB. That's what the integral is for. Then we take the square root. So ibig sabihin, pag malaki yung L2 norm, malaki yung area under the curve of f squared. So kaya global siya. Kasi nagmamatter yung nagmamatter yung function value sa bawat point. Tapos kasi sinasum up natin sila, so meron silang contribution. Kaya global, kasi bawat point may contribution dun sa L2 norm. Whereas dun sa L infinity norm, local siya kasi isang point lang yung nagsasabi sa atin kung ano yung L infinity norm. Kasi kinukuha lang natin yung supremum o yung pinakamataas na absolute value. Dito sa L2 norm, sinasum up natin yung mga function value ni f squared. Right? Laging yung sinasum up natin ay naka-quotation marks kasi it's an integral, right? Because there are infinitely many points on the interval AB. So, integration talaga yung ginagamit, hindi summation, right? So if you will interpret the function f to be the error function, when you talk about the L infinity norm of the error or the error f, so ibig sabihin kinukuha mo lang yung pinakamalaking posibleng error dun sa interval AB, and that is our measure of error for the interpolation process. Pero pag kinuha mo yung L2 norm, kinukuha mo yung may pinakamaliit na sum ng squares ng mga errors over the entire interval. So, yung mga errors, yung mga maliliit na errors, nagko-contribute pa rin sila dun sa L2 norm. Whereas, hindi sila nagko-contribute dun sa L infinity norm kasi yung pinakamalaking error lamang yung tinitingnan natin kapag we're talking about the L infinity norm. Alright? So I hope it's clear. L infinity norm is much more of a local measure of error, while the L2 norm will give us a more global sense of the error. Okay? So, yun yung titingnan natin ngayon. How do we optimize the optimization process with respect to the L2 norm? Ano yung mga X of J's na pipiliin natin para mapaliit yung L2 norm ng ating interpolation process or ng error ng interpolation process? So sana kaya nyo nang i-explain sa problem set. Sa problem set kasi may essay part. Pwede kong itanong, ano yung pinagkaiba ng L2 norm sa L infinity norm with respect to quantification of the error, right? Or I can say, explain why we can say that the L2 norm of the error is much more of a global take on the error, while the L infinity norm is much more of a local take on the error. So parang gano'n, pwede ko yung itanong sa problem set, all right? Okay. So yung titingnan natin, ano dapat yung mga x of j's para mapaliit yung L2 norm ng error. Well, for that, we will use what we call the Legendre polynomials. Okay. The Legendre or Legendre polynomials. Probably I'll pronounce it as the Legendre polynomials. You know? So the Legendre polynomials is a family, again, of polynomials defined on the interval -1 to 1. So ganun ulit, parang Chebyshev lang. Nandun lang tayo sa interval -1 to 1. But this time, I'll give you only one definition for the Legendre polynomial. Hindi katulad ng Chebyshev na meron tayong trigonometric definition at saka polynomial recursive definition. So for Legendre, I'm going to give you the recursive formula for them, all right? So ito yung formula para sa P sub n of x. So it's 2n minus 1 over n times x times the previous Legendre polynomial minus n minus 1 over 2 times the Legendre polynomial 2 steps back, right? Where n actually is the degree of the Legendre polynomial. So here's our initial condition. The degree 0 Legendre polynomial is 1, and the degree 1 Legendre polynomial is simply x. So magkamukha sila ng Chebyshev polynomials ng initial condition. Now to find higher order or higher degree Legendre polynomials, so we'll just use the recursive formula. So when n is equal to 2, we will get the degree 2 Legendre polynomial P sub 2. And this is basically 2 times 2 minus 1 over 2 times x times the previous Legendre polynomial minus 2 minus 1 over 2 times the Legendre polynomial 2 steps back. All right? Ito pala magkakaroon ako ng abuse of notation kasi usually ang notation natin, ang P sub n ginagamit natin sa AIP, ano? Ngayon ko lang siya napansin. So it would be an abuse of notation, pero hopefully it would be clear in context when whether I'm talking about P sub n being the Legendre polynomial or P sub n being the degree n AIP, right? So if you simplify this, you will get 3 halves x times x minus 1 half times 1. So that's 3 halves x squared minus 1 half. So this is the degree 2 Legendre polynomial, right? So that's what we got there. And then to get P sub 3, you again go through this recursive definition and use n equals 3. So you'll get 5 halves x cubed minus 3 halves. And it seems that what observation can we make about the Legendre polynomials? Well, the Legendre polynomials are also not monic, all right? Can anybody remind me, ano nga yung ibig sabihin pag hindi monic? Or you can also answer in the negative, kailan naman siya monic? And then plus, paki-explain kung bakit hindi siya monic. Hey, thank you, Kiefer and Ned. Oh, thank you rin, Ray and Nicolette and John Rancis, Neil and Dino. Yes, monic siya kapag ang leading coefficient ay 1, right? And it's of course not monic if the leading coefficient is not equal to 1. So thank you, Bernadette and Kian, for answering us as well. So nakita natin dito, si P2 3 halves yung leading coefficient, so hindi na siya monic. Oh, thank you, Bryle. That's also right. Tapos, tingnan niyo yung pattern, ano? So, kung ito si degree 2 Legendre polynomial, pagpupunta na ako dun sa degree 3 Legendre polynomial, yung 3 halves x squared minus 1, imumultiply ko ng 2n minus 1 over n. Kapag kasi n ay 3, this multiplier is what? This multiplier is 5/3, right? So 5/3, mamumultiply itong P2 times x, right? So magkakaroon ako ng what? 5 over 2x cubed plus some lower degree terms. So hindi na siya magiging monic, right? Kasi every step of the way, namumultiply yung previous Legendre polynomial by 2n minus 1 over n times x. Wala dyang mga magka-cancel. So laging may matitirang coefficient si x to the power n na hindi equal kay 1. So you can do this by, you can write the proof na hindi monic ang Legendre polynomial starting for degree n, for degree 2, using the principle of mathematical induction and using the recursive formula for the Legendre polynomials. Okay? So tapos ganun uli, katulad ng ginawa natin sa Chebyshev, sir, what's with Legendre polynomials that makes them very very useful for minimizing the L2 norm of the error? Because again, that's still our end goal, right? So tingnan natin, ano yung magandang properties ng Legendre polynomials. But before I forget, caution pala, because I was also browsing through some of the lab exercises that you submitted. And some of you just call the Chebyshev polynomials from MATLAB kasi may command si MATLAB para tawagin yung Chebyshev polynomials. And actually, there's also a built-in command para tawagin yung Legendre polynomials para hindi nyo na ipoprogram in a for loop itong recursive definition na ito. But be careful when using those intrinsic commands kasi hindi lang isang klase yung mga Legendre polynomials. So I'm just calling them Legendre polynomials here or Chebyshev polynomials above because these are the basic ones. But in higher math, marami pang klase ng Chebyshev polynomials. May Chebyshev polynomials of the first kind, of the second kind, and ganun din sa Legendre. So pag gumamit kayo ng built-in command kay MATLAB, siguraduhin niyo muna na yung ginagamit yung polynomial ay exactly kung ano yung nasa vertex. All right? So kasi baka Legendre polynomial, I don't know if this is called the Legendre polynomial of the first kind in MATLAB. Kaya lang baka pag ginamit niyo yung Legendre command ni MATLAB of the second kind yung ibigay sa inyo. So medyo mamamali yung mga x sub j's na makukuha nyo, right? So make sure you're using the right command. So read the documentation. So wag lang basta-basta gamit ng intrinsic command. Double check nyo kung yung ba talaga yung command na gusto nyong gamitin, all right? Makikita nyo naman sa documentation yung mathematical definition o ano yung mathematical formula for the built-in commands. So just make sure, ano, kasi baka magtaka kayo, sir, hindi ko nakukuha yung nasa Xer, yung nasa vertex, iba po yung nakukuha kong AIP kasi baka naman yung Legendre polynomial ay hindi as defined using definition 3.4. Okay? So medyo ingat lang. Oh, by the way, also, baka makalimutan ko rin, whenever you want to, whenever you have extension requests or hindi kayo nakapagpasa ng isang lab exer, kindly talk directly with your lab instructor kasi sila yung magde-decide about lab exercises. Ano? Ako lang yung tagagawa ng lab exercises at saka isang version ng answer key, pero lab instructors niyo yung magde-decide. Alright? Okay. Now, yung Legendre polynomials, yes, Mitzi, just type in your question about Chebyshev formulas, and then I'll go back after I introduce the properties of Legendre polynomials. Ano? Legendre polynomials basically this arise as a solution from an ordinary differential equation. Or actually, yes, solution siya ng isang ODE which we call the Legendre differential equations. So dun talaga siya nanggaling. And the nice thing about Legendre polynomials, meron siyang linear algebra properties that makes it very useful in applications like in functional analysis, in approximation theory, and so on. Mayroon siyang alternative definition, pero as a solution of a differential equation. And I don't want to assume that you have taken ODE or Math 151, kaya I'll stick to the basic. Ganito ko na lang i-define yung Legendre polynomials. Alright? Pero yun yung background ng Legendre polynomials. Actually, the Legendre polynomials form an orthogonal or orthonormal. I think at least an orthogonal family of polynomials. And we will see ano nga ba yung ibig sabihin ng orthogonal family of polynomials, ano? Or at least yeah, makikita natin yung term ng orthogonal polynomials. I thought hindi, pero nandito pala siya sa theorem later. Pero some preliminaries from linear algebra that will help us understand ano yung ibig sabihin ng mga properties ni Legendre polynomial. Well, first we can say that a set of polynomials, or in general, a set of objects, is linearly independent. Ano? So akala nyo hindi nyo nagagamitan yung sa Math 105 or Math 120 nyo. No? Pero we say a set of objects or mathematical objects is linearly independent if this linear equation has only the trivial solution. All right? So si B1 hanggang si Bn ay linearly independent kapag kinuha mo yung linear combination nila with unknown coefficients, inequate mo kay 0, nag-iisa lamang yung solution, which is all of the c sub i's are equal to 0. Kung wala kang non-trivial solution, meaning wala kang solution na at least isa sa mga c sub i's ay non-zero, then we say that our set is linearly independent. Okay? So, kailangan para ma-check yung linear independence, kung matatandaan nyo sa 120, isosolve nyo itong equation na to, look for the c sub i's, and if there's only one solution, which is basically the c sub i's all being equal to 0, then your set is linearly independent. Okay? And then a set of polynomials spans or is a spanning set of a set X if lahat ng x's na nandun sa set X can be written as a linear combination of the b sub i's. Alright? So ito naman sinasabi, kailan ini-span ng isang set ang isa pang mas malaking set. Alright? So meron kang subset, halimbawa set of polynomials B1 hanggang Bn, masasabi natin na ini-span ni B1 hanggang Bn yung set of polynomials X kapag ka lahat ng polynomial kay capital X ay pwede nating isulat as a linear combination ng mga b sub i's. Alright? So parang ano to, itong set na to ay parang siya yung building block ng buong or sila yung mga building blocks ng buong set X. Alright? Because any element in the set X can be written as a linear combination of the b sub i's. Alright? So ito yung pagiging spanning set. Kaya mong isulat lahat ng elements ni capital X as a linear combination. Ito yung tawag natin sa linear combination. Ano lang siya? Constant times yung mga elements ng mga sets, tapos kukunin mo yung summation ng mga product, yun si capital X. So ini-span ng set na to si capital X kapag ka lahat ng elements ni capital X, say little x, ay kaya mong isulat in this manner. Okay? And then lastly, huli na to from linear algebra, two polynomials are said to be orthogonal over the interval AB with respect to a weight function if the integral ng f of x times g of x times the weight function ay equal kay 0. Okay? So integrate mo lang si f times g times the weight function over the interval AB. Pag equal siya kay 0, then masasabi natin na si f at saka si g ay orthogonal dun sa interval AB with respect to the weight function W. Okay? Tapos papakita natin yung paano na satisfy ni Legendre polynomial yung tatlong conditions na yan. Alright? Okay. May question sa chat. Hold on. Habang ina-absorb niyo yung definitions from linear algebra. Tingnan ko lang yung question. Okay. About the number of fruits, 3.1. O talaga, sana wala akong typo, pero tingnan natin. Okay, 3.1. Okay. So, tingnan natin yung remark 3.1. No? So, number 5. Okay. So, take note, ang tanong ni Mitzi ay ganito. Saka tanong na rin ni Neil. Ano? So, dito sa formula na to, yung formula for scaled Chebyshev roots, yung n po ba roon sa n plus 1 sa denominator? So, Is it remark 3.5, 3.1 number 5? So probably you're referring to here. Okay. Yung kaya lang wala ditong 2, walang n plus 1 sa denominator. Or you're referring to here. Okay. So, clarify ko na lang. So, sa remark 3.1, yung binibigay ng remark 3.1 ay properties ng T sub n, which is the Chebyshev polynomial of degree n. Okay? So, pag ginamit niyo yung 3.1.5, ibibigay niya yung roots ng T sub n, degree. Naputol yata ako doon. But again, what we're trying, in remark 3.1, it's giving us properties ni T sub n, degree n Chebyshev polynomial. So kung meron kang degree n Chebyshev polynomial, meron kang n na simple roots. Tapos ito yung formula para dun sa roots niya. 2j minus 1 over 2n times pi times cosine. Right? So ito yung roots ng degree n Chebyshev polynomial. So, ibig sabihin, pag n is equal to 5, makukuha mo yung degree 5 Chebyshev polynomial, meron siyang 5 roots. Okay? Meron siyang 5 roots, so ibig sabihin, degree 4 lang. At most, yung interpolating polynomial na makukuha mo. Right? Kasi ito ay property ng Tn, hindi property ng degree n AIP. So, if you're using this formula, may makukuha kang n distinct roots. Tapos yung n distinct roots na yun, pag ginamit mo sa interpolation, you will get a interpolating polynomial of degree n minus 1. Okay? So I hope that's clear. Tapos dito sa remark sa ilalim, okay. Meron akong I going from 1 to n plus 1. So dito inassume ko na ang ginagamit kong roots ay mga roots para sa degree. Okay, sorry, meron yung typo. Ito ay roots para sa degree. Roots to para sa degree n plus, sorry, ito yung translated roots para sa degree n interpolating polynomial. So, ibig sabihin, tingnan ko nga yung roots ulit. Oh yeah, thank you for asking that. So, ngayon ko lang siya napansin. Hold on. At yung formula para dun sa bawat roots, j going from 1 to n, roots to ni tn. Tapos itong x sub bias dito, siya dapat yung mga roots ni t sub n plus 1. Right? Root siya ni t sub n plus 1. So the formula here should be so sorry, dapat ito ay 2n. Hold on, 2n plus 1. Tapos ito ay, hindi, tama pala, 2i minus 1 over 2 times n plus 1. Yeah. So itong mga to, ito yung roots ni t sub n plus 1. So pag in-apply ko yung formula ng 3.1.5, makukuha ko yung mga xj's. So lahat lamang ng n's, papalitan ko ng n plus 1. Kasi ang assumption dito sa part na to, kukuha ko ng AIP of degree n. So kung meron akong AIP of degree n, kailangan ko si Chebyshev polynomial of degree n plus 1 para makakuha ko ng n plus 1 roots, right? This is the formula for the roots of t sub n, but I need the roots of t sub n plus 1. So what I'll do is I'll replace all n's that I see here in this in the formula for the roots by n plus 1. So I'll have 2i minus 1 over 2 times instead of n plus 1 na yung denominator kasi nga ang kinukunan ko ng roots dito sa formula na to ay roots ni t sub n plus 1. Alright? Tapos yung j dito going from 1 to n lang siya supposedly, pero dito it will go from 1 to n plus 1. Kasi nga ito ay roots ni t sub n plus 1, alright? Ang tinatranslate niya, pero itong formula na to ay para sa roots ni t sub n. Okay? So I hope that's clear. So wala pala, walang corrections dun sa handout. Tama yung handout. Magkaiba yung kinukunan ng roots. So remark 3.1, property siya ni t sub n. Pero dito sa translation formula, tinatranslate ko ay n plus 1 abscissas. So ibig sabihin, ito ay mga roots ni t sub n plus 1. Okay? So be careful dun sa numbering, ano? Or dun sa counting. By the way, if you want pala, pwede kong i-discuss yung solutions dun sa mga laboratory exercises. Kaya lang ang problema ko ay hindi kasi tumatanggap kasi kami ng late submissions, ano? And it would be unfair, I think it's unfair kung i-discuss ko siya dito sa klase, ano? Siguro I'll schedule a consultation hour, ano, where I will only discuss yung mga solutions. Or probably kung maaga ba kayo natatapos ng laboratory tuwing Monday? Kaya lang alam ko pag Monday busy na kayo paggagawa ng lab exercise. So hindi ko alam kung paano natin isisingit yung discussion ng solutions. Unless magiging strict ako na after the closing of the submission bin in Canvas, hindi na kami tatanggap ng late submissions para ma-discuss ko yung solution ng lab exer sa lecture, ano. Though I will be uploading I'll be uploading the answer keys. So pwede niyong basahin din yung aking solutions, ano. I'll upload the answer key ng 1.2 and 2.1 later this week. Ready na siya pero nakita ko marami pang hindi nakakapagpasa, so ayoko munang i-upload para hindi kayo ma-tempt na basahin siya kahit hindi pa kayo nakapagpasa, ano. But essentially that's that. Ayan, nakalimutan ko yung mga announcement ko sa simula. And then I also look at the answers dun sa survey if you want to go face-to-face after the reading break. And there are some of you who said hindi nyo kakayaning mag face-to-face. So that means we will retain the M1 mode for the entire semester, ano? So hindi na tayo mag-shift sa face-to-face for this semester. Parang may 20 plus na nagsabi na hindi nila kayang mag face-to-face, ano. So we'll honor the M1 mode for this class, okay? So let's look at the properties ng Legendre polynomials, ano. So we will consider the Legendre polynomials and denote them by P sub n, or the P sub i's, right? Where I is the degree of the Legendre polynomial. First is the observation that we laid down earlier, that P sub n is not monic when n is greater than 1. Simula sa degree 2 pataas, hindi na siya nagiging monic. And basically, the proof will be by induction. You start with n equals 2 and show na, or illustrate. Kasi alam na naman natin si P2, sabihin nyo lang na si P2, dahil ang leading coefficient niya ay 3/2, siya ay hindi monic. Tapos, gawin niyo yung basis step and so on. And basically, the reasoning there for PMI ay kasi namumultiply siya lagi ng, anong multiplier niya? 2n minus 1 over n. So never maka-cancel into 1 yung leading coefficient ng higher degree Legendre polynomial. So you can try writing a proof for it. Baka lumabas sa problem set, ano. So sa problem set, may mga proving items din. So pero kukunti lang naman yung posible kung mga ipa-prove, ano. So just watch out for them. Tapos number 2 is about the orthogonality of the Legendre polynomials over the interval -1 to 1. Because basically, this is telling us that the integral ng product ng dalawang Legendre polynomials over the interval -1 to 1 is either 0 pag magkaibang Legendre polynomial yung pinag-multiply ko. Tapos kapag kaparehas sila, ang product nila ay 2j, 2 over 2, yung integral nila ay 2 over 2j plus 1. Right? So if I take, say, the degree 1 Legendre polynomial, multiply it with the degree 7 Legendre polynomial, tapos nag-integrate ako over negative 1 to 1, ang sagot ay 0 kasi j is not equal to k. Alright? So, laging 0 kapag ka nag-integrate ka ng product ng dalawang Legendre polynomial over the interval negative 1 to 1 where their degrees are not equal to each other, then 0 yung makukuha yung value. But if you will integrate a Legendre polynomial against itself, say you're integrating P2 against P2, ang sagot doon ay 2 over 2 times 2 plus 1. So 2/5 yung makukuha nyo na integral from negative 1 to 1. But essentially, if you remember this, all right, kapag ka equal kay 0 yung product ng integral times some weight function, siya ay orthogonal. So from property number 2, whenever, ibig sabihin, the Legendre polynomials are orthogonal to each other with respect to the weight function w of x is equal to 1. Remember, para maging orthogonal, ito yung definition. F times g times w of x dx must be equal to 0 over the interval AB. Ito yung general definition. Here, our interval AB is negative 1 to 1. Tapos, your f of x is one of the Legendre polynomials. G of x is a different Legendre polynomial. You take w of x is equal to 1. Ang integral na yun ay laging 0. So we can say na orthogonal family yung mga Legendre polynomials. Okay? Unfortunately, or siguro luckily for us, the proof of property number 2 will require some things from ODEs. Ano? So kailangan, para madaling ma-prove itong property number 2, kailangan natin yung definition ni Legendre polynomial coming from as a solution of a differential equation, tapos mag-i-integration by parts tayo doon. Alright? So may property na kailangan from dun sa differential equation kung saan na-derive yung Legendre polynomials. And since 151 is not a prerequisite of this course, hindi natin na ipoprove yung property number 2. Alright? So paniwalaan nyo lang ako na orthogonal yung mga Legendre polynomials on the interval negative 1 to 1 with respect to the constant weight function 1. Okay? And then third is that P0 until Pk. So if I get the first K Legendre polynomials, kukunin ko lahat ng Legendre polynomials na ang degree ay K or less. Sila ay linearly independent, okay? Tapos hindi lang sila linearly independent. Ini-span pa nila yung space of all polynomials of degree at most K. Sa mga nag-120 or 105, does that ring a bell? Ano yung tawag sa linearly independent set na ini-span yung buong vector space? Naalala nyo ba? Or ayaw nyo ng ganito na pinaghalo-halo yung mga math courses? Kasi essentially later you will realize na magkakaano yan, magkakatahi yung mga magkakaibang subjects sa math. Ano? So, does anyone remember ano yung tawag sa isang set na linearly independent tapos ini-span niya yung buong vector space? Nice try, Nicolate, but that's not what I'm looking for. Pero I think subspace to. Isang subspace ito ng vector space. Pero isa siyang special na subspace. Nice try din, Elgin, pero I'm afraid that's not the term I'm looking for. Sige, starts with the letter B. Ayan, may clue na. Ayun, nakuha na ni Nicolate sa ni Ray. Yeah, yung basis, right? Yes, Marco, Kiefer, yeah. So yung Legendre polynomials of degree K or less, siya yung isa siyang basis para sa space of all polynomials of degree at most K. Ano muna yung ibig sabihin ng linearly independent? Pag kinuha mo yung summation ng C sub I times P sub I, in-equate mo kay 0, wala na siyang ibang solution kundi yung trivial solution na lahat ng C sub I ay equal kay 0. Tapos ang kagandahan nito, ini-span niya yung set of all polynomials of degree at most K. Ibig sabihin, kahit anong polynomial yan of degree at most K, kaya ko siyang isulat in terms of the Legendre polynomials of degree K or less. So ibig sabihin, pag may naisip ka na polynomial na halimbawa naisip mong polynomial ay a of x. Kahit anong polynomial yan with degree less than or equal kay k. Alright? So kahit ano pang polynomial na ang degree ay less than or equal to k ay kaya kong isulat as a linear combination ng mga Legendre polynomials. So ibig sabihin, I can write a of x to be c sub 0 times the degree 0 Legendre polynomial plus constant times degree 1 Legendre polynomial plus c2 times degree 2 Legendre polynomial plus until ck times p sub k of x. So, ibig sabihin, kahit gaano pa kakomplikado yung polynomial na iisip mo, kaya ko siyang isulat in terms of the Legendre polynomials. Kaya parang building block ng mga polynomials of degree k or less yung Legendre polynomials. Because whatever polynomial of degree k or less that you can think of, kaya ko siyang isulat in terms of Legendre polynomials. So para ito yung analog ng factoring sa arithmetic Yun nga lang multiplication yon. Kahit anong number, however big it is, kaya ko siyang i-express in terms of prime factors. Sa vector spaces naman, dahil hindi tayo nagmo-multiply ng mga vectors in general, nagtitake ng scalar products saka addition ng vectors, yung analog niya, paano natin din-decompose o sinisimplify yung pagkakasulat ng isang polynomial or isang element ng vector space that is via a linear combination. Alright? So kaya ganito, lahat ng polynomial may gantong expression. Kaya mong isulat in terms of the Legendre polynomials. Okay? Again, unfortunately, sa atin theoretically, pero practically, it's a good thing for you na dun sa proof ng 3, kailangan ko yung i-manipulate yung properties na magagaling sa proof ng number 2. So kaya hindi ko itatanong sa problem set at hindi ko rin ipoprove sa klase yung property number 3. Kasi meron mga ODE properties o some properties that are beyond the scope of the course na kailangan gamitin sa proof ni number 3. So kailangan niyo uling maniwala sa akin. So ito ay proof by appeal to authority. So I'm telling you, totoo ito. Itong property number 3. Alright? So ang Legendre polynomials of degree k and less ay isang basis para sa vector space of all polynomials of degree at most k. Alright? Ang ipoprove na lang natin ay si number 4. Si P sub n ay orthogonal sa lahat ng polynomials of degree less than n over negative 1 to 1 with respect to the weight function w of x equals 1. So basically, nakita na natin na yung mga Legendre polynomials ay orthogonal sa isa't isa. Kaya ang tawag sa kanya isang orthogonal basis. Kasi isa siyang basis tapos orthogonal sa isa't isa yung elements ng basis natin, which would be the Legendre polynomials. Pero property 4 goes a little bit further. It is telling us that the Legendre polynomials ay laging orthogonal sa kahit na anong polynomial na ang degree ay less than n. So basically, pag in-apply ko yung definition ng pagiging orthogonal, this is what we want to show. We want to show that for all polynomials q with degree of q less than or equal to n, alright? Kasi sabi ng theorem natin, dapat ang degree niya ay at most n, alright? Pag kinuha ko yung integral from negative 1 to 1, then degree n Legendre polynomial times the given polynomial times the weight function. Ang weight function natin ay 1. Sabi dun sa theorem, orthogonal siya with respect to the weight function 1. Ito daw ay equal kay 0. Ang saya kapag ka nag-integrate ka with a degree n Chebyshev polynomial. Legendre polynomial. Hindi mo na kailangan mag-IBP. Kasi pagka meron kang meron kang Legendre polynomial, i-integrate mo siya against any polynomial of degree n or less, laging equal kay 0. Degree strictly less than n pala to. Tama ba? Dapat degree less than n. So, ang degree pala nito dapat mas mababa kay n. So ito ay degree n, Legendre polynomial. Si Q ang degree niya ay hindi lalampas ng n minus 1. Okay? This is degree n. This is degree less than n. Alright? Ang integral niya ay equal kay 0. So walang problema. Pag meron kang Legendre polynomial, kukunin mo yung integral niya against any polynomial of degree less than n, sure ka lagi equal kay 0 yung integral. Alright? And for this, we can prove this using just elementary properties of the integral. So tingnan natin. Okay. So tingnan natin yung proof. Okay. Meron ng polynomial Q na ang degree niya ay less than n. So ibig sabihin, ang degree ni Q ay at most n minus 1. By property number 3, dahil ini-span ng mga Legendre polynomials ang space of all polynomials of a certain degree, tapos si Q ay degree at most n minus 1. Ibig sabihin si Q ay kaya kong isulat as a linear combination of the first n minus 1 Legendre polynomials. Right? Kasi nga basis ng set of all polynomials of degree at most n minus 1 yung unang n minus 1 Legendre polynomials. So ibig sabihin si Q, kaya ko siyang isulat as a summation ng multiples ng mga Legendre polynomials of degree n minus 1 or less. Alright? So ginamit ko dito yung pagiging span nung set of Legendre polynomials, yung vector space of all polynomials. Kahit anong polynomial ng degree ay n minus 1 or pababa, kaya kong isulat as a linear combination ng mga Legendre polynomials na ang degree ay hindi lalampas ng n minus 1. Okay, is that good so far? 1 minute na lang pala. Sorry, tapusin ko lang yung proof nito, then I can let you go. But if you have classes you have to run, you can leave the meeting. All right? Okay, so mukhang okay pa, no? So si Q, kaya kong i-represent o isulat gamit yung mga Legendre polynomials. So dun sa integral na gusto nating i-check kung equal kay 0, remember our target, show that this is equal to 0. So tell this, I'll calculate this. Straightforward calculation. Pero alam ko na si Q, kaya kong isulat in terms of the Legendre polynomials. So si Q, gagamitin ko lang yung representation niya in terms of the Legendre polynomials. Okay? Tapos, si P sub n, dahil independent siya kay I, pwede siyang basta-basta pumasok sa loob ng summation. Agree? So, para tong constant with respect to I, so basta-basta siyang makakapasok sa loob ng summation. Alright? So, yun yung nangyari sa next line. Pinasok ko lang si P sub n doon sa summation. Okay? Tapos, integral, tapos finite summation. Dahil linear ang integral, right? Ang integral ng sum ay sum ng integrals, pwede kong pagpalitin yung order ng summation at saka ng integral. Okay? Kaya ako makukuha yung next line. Okay? So pinagpalit ko lang yung order ng sum at saka integral. And then, meron akong C sub I. Constants yung mga yan. Di lang natin alam yung exactang value, pero yung mga C sub I sa mga constant, wala siyang variable x, so lalabas naman siya ng integral symbol. So kaya makukuha ko yung next line. Pero si C sub I, hindi na siya makakalabas ng summation. Kasi rito, meron siyang I na index, so hindi siya pwedeng lumabas ng summation. Alright? Kasi nagbabago si C sub I sa bawat term ng summation. So hanggang dito na lamang si C sub I. But we don't need C sub I to go out further because we have this guy now. Okay. So, meron tayong integral from -1 to 1 ng P sub I times P sub n. Pero ano nga si P sub I? Si P sub I ay isang Legendre polynomial of degree 0 hanggang n minus 1. Right? Because I goes from 0 to n minus 1. So, alam natin si P sub I, it represents a Legendre polynomial of degree at most n minus 1. Tapos, ini-integrate ko siya against a degree n Legendre polynomial. Right? So ito ay degree at most n minus 1. Ito ay degree n. So ibig sabihin, sure tayo kahit anuman si I, si P sub I at saka si P sub n ay magkaibang Legendre polynomial. Agree? Magkaiba sila, right? Kasi yung degree nila hindi magmamatch. Si Pi hanggang n-1 lang yung posibleng degree. Si Pn, degree n. So magkaiba silang Legendre polynomial, but we have theorem, the third part of the theorem, which tells us na orthogonal ang mga Legendre polynomials. So therefore, this integral over here is just equal to 0. Okay? So essentially, what we have is summation ng mga constant multipliers times 0. So essentially, we are just summing up zeros, so equal kay 0. And now we have shown that the integral of Pn times Q ay equal kay 0. So ibig sabihin, totoo, yung kapag ka in-integrate ko yung degree n Legendre with any polynomial of degree less than n, laging ang sagot ay 0. So that means the Legendre polynomials is always orthogonal to any polynomial of degree less than the degree of the Legendre polynomial. And that ends the proof. All right? Any questions about that? Hopefully it's clear. So hopefully nasundan. Kung di man, you can go back with the modules. Pero I hope it's clear. Medyo siguro ang pwede lang ay ano, pwede lang makahinder sa inyo ay yung medyo marami tayong terms ngayon na nakilala, no? Mitzi has a question on the chat. Bakit naging 0 yung integral? Ito. Bakit ito naging equal kay 0? Because of part 2 of the theorem. Sabi ko pala part 3, but that's part 2. Alright? Remember sa part 2 ng theorem na hindi natin pinrove, ang integral ng dalawang magkaibang Legendre polynomials ay laging equal kay 0. Alright? Tapos ito, si Pi ay degree hanggang n-1 lamang, yung pinakamalaki niyang posibleng degree, pero si Pn ay degree n. So ibig sabihin, sure tayo si P sub I ay laging iba mula kay P sub n. Okay? So ibig sabihin, ang integral na to ay equal kay 0 by part 2. Oh yes, Nicolette, what's your question about part 2?
Yung sa ano po sir, yung IE Legendre polynomial form an orthogonal set. Yung tinutukoy lang po ba sir is kapag J is equals to K?
Ang ibig sabihin, ang tinutukoy nito ay yung orthogonal set. Ang tinutukoy niyang orthogonal set ay yung P0, P1, P2 hanggang P sub K. Kung ano man yung pinakamalaking degree. Or actually, hindi pala. Lahat ito ng Legendre polynomials, sorry. Yung set of all Legendre polynomials ay isang orthogonal family. Kasi para magkaroon ka ng isang orthogonal set or isang orthogonal family, dapat pag kumuha ka ng dalawang magkaibang elements mula sa family na yon, ang integral niya ay equal kay 0. Or ang integral ng product nila ay equal kay 0. So that means if I pick any two Legendre polynomial na magkaiba, tapos in-integrate ko sila over the interval -1 to 1, ang sagot ay laging equal kay 0. Yun yung ibig sabihin na orthogonal family or orthogonal set yung Legendre polynomials. Kasi pag kumuha ka ng kahit anong dalawang magkaibang Legendre polynomial, ang integral niya from -1 to 1 ay laging equal kay 0. Kaya sila orthogonal with respect to the weight function w of x equals 0 dun sa interval -1 to 1. Okay? So pwede mo ring sabihin na si P sub j at saka si P sub k ay orthogonal silang dalawa. Basta si j ay not equal to k. So halimbawa, si P1 ay orthogonal kay P2. Si P3 ay orthogonal kay P0. Si P7 ay orthogonal kay P sub 100. Kasi sure tayo by property 2 yung integral nila ay equal kay 0. Yung integral ng product nila ay equal kay 0. So pag kinolekta mo lahat ng Legendre polynomials, magkaka-orthogonal sila against each other. So ibig sabihin meron kang isang orthogonal family. Right? Tama ba? Yun yung question mo? I hope that answers your question.
Sir, okay na po.
Alright. So ano lang, no, terminologies. So sa linear algebra or some functional analysis nyo makikita yon. Pero I hope that's okay. And I'll use these properties para ma-prove yung theorem 3.3, which is basically what we want. Ito yung magsasabi sa atin na si omega, dun sa error ng interpolation, siya ay minimal kapag ka si omega ay equal sa degree n plus 1 monic Legendre polynomial. And that's where we will start on Friday. Okay? So, konti na lang to. Ipo-prove ko lang itong 3.3. Sandali lang yung proof niya. Siguro, introduction lang ulit. Mas mahaba pa nga yata yung introduction ko sa actual class. Ano? So, remember, dun sa error term, merong omega of x. Alright? So, sinasabi ng theorem 3.3, mapapalit natin or mamiminimise natin yung L2 norm nung omega dun sa error term, dun sa degree n interpolating polynomial kapag ka ang pinili kong kapag ka si omega ay pinersa ko to be the monic Legendre polynomial of degree n plus 1. So kung si omega yung error sa interpolation using an AIP of degree at most n, so kailangan ko ng n plus 1 points. Alright? So, ayan, sabi ng theorem 3.3, mamiminimise ko si omega, yung L2 norm ni omega, kapag ka si omega ay pinili ko to be the monic Legendre polynomial of degree n plus 1. Kailangan n plus 1 siya para magkaroon ako ng n plus 1 roots. Tapos yung n plus 1 na roots na yon, siya yung gagamitin ko para ma-compute yung AIP. Alright? Sila yung magagamitin ko mga abscissas ngayon. So kung before Chebyshev yung ginamit natin para Chebyshev roots yung ginamit natin para minimize yung L infinity error, ngayon naman yung Legendre roots yung gagamitin natin para ma-minimize yung L2 norm naman ng error. So depende dun sa klase ng error na gusto nyong i-minimize. Kung L infinity yung gusto nyong i-minimize, gagamitin nyo si degree n plus 1 Chebyshev polynomial. Kukunin nyo yung n plus 1 roots, sila yung gagamitin mong abscissas dun sa Lagrange form. Kung gusto mo namang i-minimize yung L2 norm ng error, ang kailangan mong gamitin ay yung degree n plus 1 Legendre polynomial. Alright? So yun yung titingnan natin on Friday, and then I'll share with you the code that I used para sa pag-generate ng AIP kapag yung mga abscissas needs to be chosen to be the monic Chebyshev, the monic Legendre polynomial. Ano? Para makita nyo rin na parang nagagawa lang kayo ng additional line dun sa Lagrange. Nothing is new here. Alright? Lagrange pa rin yung ginagamit natin. Yun nga lang, pinipili natin yung mga abscissas na kailangan natin gamitin. Kaya naman iniisip ko sa lab extra, dapat madali lang yon kasi isang line lang yung babaguhin nyo or dalawang lines lang yung idadagdag nyo. Lalo na dun sa Chebyshev. Isang problema dito sa Legendre, wala tayong formula para dun sa roots ng Legendre. Yung sa Chebyshev, alam niyo na siya ay cosine ng 2j minus 1 over 2n. Alright? Yun yung roots ng degree n Chebyshev na makakapagbigay sa iyo ng degree n minus 1 AIP. Kaya lang dito wala. Hindi natin alam yung roots. Wala tayong formula para sa roots ng Legendre polynomials. Alright? So yun din. Papagawa rin natin siya kay MATLAB or papagawa nyo kay Python kung Python yung ginagamit nyo. So I'll share with you my code on Friday. Ayun pala, nabasa ko rin dun sa mga essays nyo. Sorry, overtime na. Pero mabilis lang. Na medyo nahihirapan pa rin kayo mag-MATLAB and there's a little bit of a disconnect dun sa AMAT 152 and MAT 174. But I'm not forcing you to use MATLAB, or I hope your lab instructors are not forcing you to use MATLAB. If you're more comfortable doing it in Python, then go ahead, use Python. If you're more familiar with Scilab, use Scilab. If you're more comfortable using Mathematica, then go ahead, use Mathematica. I don't care what programming language you use. Yun nga lang, mag-stick ako sa MATLAB dun sa demo sa klase. Alright? Because I think MATLAB is much more intuitive than Python. Alright? So, ayoko kasi yung syntax ni Python, hindi siya pangkaraniwan. I mean, hindi siya intuitive for me, So, but if you're more familiar with Python, then go ahead. Ito yung iniisip ko na i-propose sa susunod na AMAT 152. MATLAB na yung gamitin nilang programming language kasi mas madali itong matutunan. And yeah, one reason kasi nung inimbento namin yung AMAT 152 ay wala pang subscription ang UP sa MATLAB. So that is about, kailan ba yun? 2018. Saka siguro minaan na lang namin yun from previous AMAT 150 na Python or Scilab yung ginagamit, which are free softwares. Pero dahil ngayon, merong subscription ng UP sa MATLAB, I want to promote yung gamit ng MATLAB kasi sayang yung milyong-milyong binabayad ng university sa MATLAB kung hindi natin gagamitin, ano? And I heard may balak na bumili rin ng Mathematica software ang university. So siguro, pag meron na tayong access sa Mathematica, I probably can introduce you on how to use Mathematica especially for symbolic calculations, okay? But yun, thank you guys for joining me today, pagising ng maaga. And enjoy the rest of the day. And let's see each other again on Friday para dun sa code na hopefully makatulong sa LabXer 2.2 on Monday. All right? Bye, everyone.